We're finishing the back page of the Chapter 7 morning test review. So let's look at number 3 here. Find the volume of the solid formed by revolving the region bounded by y equals natural log of x. That's this curve here. The x-axis given here, and x equals 6. So we're taking the shaded region here, right? The shaded region. We are taking this and spinning this shaded region around the vertical line x equals -2. So if we're dealing with this shaded region here, notice that there's a definitive gap between this curve, or between the boundary of this shaded region and the vertical axis of revolution, x equals -2. So that means that we have to go through Washer method. So with Washer method, we have to create two radius, one that extends from the axis to the further boundary of the shaded region, and a little radius that extends from the axis to the closer of the two boundaries, right? And it's obvious that big R will be longer than little r. So and then our radius is always going to be horizontal. Always going to be perpendicular to your axis of revolution. Okay, so it's always going. So in this case, because the axis is vertical, our radius has to be horizontal. Now, if our radius big R and little r, if they're both horizontal, then we have to do right minus left. And if we do right minus left, all of the equations that we're using has to be x equals, has to be in terms of y, and then our bounds also have to be in terms of y. So that means we have to adjust the equation potentially. So this is still x equals 6. So still x equals, and we have to rewrite all the equations as x equals, but this is already as x equals. So, but this equation was y equals natural log of x. So we have to solve for x. So x equals, so we can convert this to exponential form. So x equals e to the y. So this curve is e to the y. Now we have the equations that we need. So we do right minus left. So for big R, it'll be 6 minus a -2. So 6 minus -2 is 8. And little r will be e to the y. That's the right endpoint of the radius is hitting this curve. So e to the y minus -2. So then that's e to the y plus 2. So we have big R and little r, and we can create our volume equation, which is pi integral from the lowest y value, 0, to the highest y value. So the highest y value is going to be the intersection of this line, x equals 6, and x equals e to the y. So if we set the two equations equal to each other, take the natural log of both sides to solve for y, we get y equals natural log of 6. So the y value of the highest point of the shaded region is going to be natural log of 6. So we have our lower and upper bounds. We also have our big radius squared, so 8 squared, minus little r squared, so e to the y plus 2 quantity squared. And then all this can be plugged in the calculator, and we get 70.006 pi. All right, number 4. Here, this is from 8.2, where we have to do integration by parts potentially. So if we have to do integration by parts, we're going to have to look to see what the two separate functions that we're trying to pair up with. So here we have natural log of x, and then we also have dx. So we're using having to compare between that natural log, and we can call this algebraic expression here, or 1 dx. So if that's the case, then anytime we see natural log and we're going through integration by parts, we're always going to have to assign the u value to be the natural log portion. So it's going to end up being integral of u dv is equal to u times v minus integral of v times du. So here's the formula we'll be using. We have to assign our u and dv. So u, if we see natural log, it will always be natural log. So natural log of x cubed. So our dv will be dx. On the u side, we're going to find the derivative. So u becomes du over dx. Natural log of x cubed becomes we can go through u prime over u, so 3x squared over x cubed. And then for the dv side, we have to take the integral. So integral of 1 dx becomes 1x. Solve for du. So du, simplify this some more. We get 3 over x dx. So then we can plug into our formula. So this is u dv, integral u dv equals u times v. So u is natural log of x cubed times v, which is x, minus the integral of v du. So v times du. And v times du can simplify. The x's cancel out. Integral of 3 dx. Now this is already finished. We just have to always take the extra step to take care of the integral of v du. So integral of 3 is simply 3x, and then we have the plus c. All right, number 5, we have natural log of y and y squared here. If we bring the y squared up to the top, we have natural log of y, and y equals y to the negative 2. Again, anytime we're pairing up two separate families of functions to each other, we could potentially go through integration by parts. So again, if we're having to go through integration by parts, our u value, if we see natural log, it'll always be assigned to be a u value. And then the other, in this case, also algebraic, will be the dv. So u is natural log of y. dv is y to the negative 2. On the u side, we find the derivative, so u prime over u, so 1 over y dy. The dv, we have to go through power rule. So it becomes y to the negative 2 becomes y to the negative 1 over negative 1, or negative 1 over y. So now we go through, we plug in the rule for integration by parts, so u times v. So u times v, so pair these together, minus integral of v times du. So we have v and du. This portion is done. Just have to simplify a little bit further. This portion, we still have to take the indefinite integral. So combine this to be negative 1 over y squared, or y to the negative 2. So integral of y to the negative 2, we go through power rule, becomes y to the negative 1 over negative 1, and then we have a plus c at the end. Number 6, integration by parts. Here we're pairing polynomial or algebraic versus exponential. So if we're able to assign the u value to be algebraic, then we can go through tab method. So tab method allows us to efficiently go through integration by parts, especially if in this case integration by parts requires repeated methods. So to speed up the process, we can just list out everything that we need, and then pair up the ones that are going to combine together. So on this side here, our u value will be x cubed, our dv will be e to the negative 2x. On the u side, we're going to keep finding the derivative until we hit 0. And then on the dv side, we're going to keep finding the indefinite integral until we reach the same level as how many times it takes to get to 0. So x cubed, we go through derivative, becomes 3x squared, derivative 6x, derivative 6, and then finally the derivative of 6 is 0. So that's where we stop. On e to the negative 2x side, we have to find the integral. So let's step over here and see the process here. If we want to go through e to the anything that's more than just x, we have to go through u substitution. So our u value is negative 2x. Find the derivative is negative 2. Solve for dx. We get du over negative 2. We make our substitutions. Negative 2x becomes u. Dx gets replaced with du over negative 2. Now there's a coefficient that pulls out negative 1/2. So integral of negative 1/2 e to the u is simply negative 1/2 e to the u plus c, and then our u value is negative 2x. So notice that every time we step through the integral process, the u value of negative 2x will always produce a negative 1/2. So the first iteration will give us negative 1/2 e to the negative 2x. If we find the integral again, our u value will be negative 2x. So the procedure will always produce a negative 1/2 coefficient. So if I take the integral again, I'm going to have another negative 1/2 to have to put in front of, to have to multiply to in front of this coefficient. So negative 1/2 times negative 1/2 becomes 1/4. And then we go through integral again, 1/4 times negative 2, because of the negative 1/2 that will be produced from this u value here. So 1/4 times negative 1/2 becomes negative 1/8. Integral again, negative 1/8 times 1/2 becomes 1/16. Okay. And then the way that these terms are paired up will be diagonals to each other. And also, each time we find the integral, there's always going to be an opposite sign that will be causing a change in signs. So the way we keep track of it is we do we alternate signs starting with the plus. So plus, minus, plus, minus, plus. So now what happens is we're multiplying positive 1 with x cubed with negative 1/2 e to negative x. So all these three combines to be the first term. Okay, and then negative 3x squared, negative 1 times 3x squared times 1/4 e to the negative 2x, that becomes the second term. And what I did here was, I think I skipped a few steps. I factored out the e to the negative 2x. So technically, here's what is occurring before all the terms get, before the e to the negative 2x gets factored out. E to the negative 2x times 3/4 x, and then e to the negative 2x times 6/16. All right, and so let's see, the next one is positive 1. So positive 1 times 6x times negative 1/8 becomes negative 3/4 e to the negative 2x. And then finally, negative 6 times 1, sorry, negative 1 times 6 times 1/16 e to the negative 2x becomes negative e to the negative 2x times 6/16 plus c. And then there's no other diagonals to combine. And then here, notice that we have common factor of e to the negative 2x for each of the terms. So we can factor out a e to the negative 2x. And then the rest of the terms will just go in the parentheses, and then we have a plus c. Number 7, determine the area of the region bounded by y equals 2x squared plus 10, y equals 4x plus 6, x equals negative 2, and x equals 5. So here's x equals negative 2, and then here's x equals 5. Now, if we want to find the bounded region, notice that there's 3 bounded regions, and essentially we're going to have to alternate the top minus bottom for each of these intervals. Anytime the curve flips to above or below the line, we're going to have to think of these as separate area problems. So the first region, the top curve will be the quadratic, so 2x squared plus 10 minus the linear equation, 4x plus 16, so top curve minus bottom curve, from negative 2 to negative 1. So and then we can find these critical points by setting the curve equal to the line. That's the first region. Okay, and the second area region will be, notice the curve and the line has flip-flopped. So the top curve for the middle region is now going to be a linear function. So if we do top minus bottom, it'll be 4x plus 16, which is linear, minus the curve, which is 2x squared plus 10. And then the bounds are going to be from negative 1 to 3. So okay, so from negative 1 to 3, top curve minus bottom curve. And then finally, the third region, the curve is now back on top. So we have 2x squared plus 10 minus the linear graph, which is 4x plus 16, and the bounds from 3 to 5. And then we can either go through power rule or plug in the calculator. And the first area region, the left area region, will produce 14/3. The second region will be 64/3, and the third region is 64/3. And we add those together, we get 142/3 as the area of these 3 shaded regions combined together.